Do you feel the vibes?
Like, so in chapter 1, we are no longer going to use the set notation for our intervals, right? So no longer like x is less than or equal to, or 1 is less than x less than. It's going to be the interval notation, right? Okay, so let's start with functions. Okay, a function is basically a relation which maps, a set A to a set B. Okay, and in that set A, right, everything in set A is the domain, and everything in set B is the range. But to make it a function, each value in the domain maps only to one number in the range, right? So for example, if you have, x equals 3 in the domain, it will only map to 1y in the range, which means no 2 points on the graph of a function can lie on the same vertical line, okay? Or no 2 different pairs of coordinates will have the same x value. If you have the graph, you can do the vertical line test, which we all know, right? You draw a series of vertical lines, and it's only allowed to cross the graph once. Okay, so let's take a look at these and see if each of these is a function. So for when you have coordinates given to you, you basically look at the x's, and as long as none of the x's repeat, then yes, it's a function. If you have a table of values, same thing. Look at the x's. You see here the x's repeat, right? You have 2 2's, but with different corresponding y values. That means this is not a function. This one, by the vertical line test, it's definitely a function. This one here, when you have a function given to you, it is useful to look at it in terms of, y equals the rest of the function, right? So let's solve it for y. So x over 2 will be y squared. And then when I take a square root, I basically get y equals plus or minus x over 2. That already tells me this is not a function, because suppose x was equal to 1, right? So let x equal 1. Then, so then y, right? If x is equal to 1, then y will equal to positive 1 over root 2 and negative 1 over root 2. So you cannot have 2 different y values for the same x. That means this is not a function, right? So that's what you kind of have to look at, right? You have to think, okay, if I put in an x value, how many different y values am I going to get? Okay, we all know about function notation, right? F of x is basically, it corresponds to y values, right? And if I have, y equals f of x, x is all of the values that are in the domain of f, and it is the independent variable. And y, or f of x, is the range, and it is the dependent variable. Okay. Now, in the last chapter, chapter 4, remember I would give you like sine of x or cosine of x, and I would say find f of x plus h minus f of x over h, right? We're going to do that again. Now it's not f of x plus h, now it's f of a plus h, but it's the same thing, right? So for each function here, we're going to find number 1, f of a, and then number 2, this difference quotient, f of a plus h, blah, blah, blah. Okay, so if f of x is this, then f of a is just a squared minus 2a, right? So now we're going to build this. So this is f of a plus h minus f of a all over h. Okay, let's see what f of a plus h is, right? So if f of x is x squared minus 2x, f of a plus h, right, will replace each of the x's with a plus h. So a plus h squared minus 2a plus h. Now I'm going to expand this. So this is going to be a squared plus 2ah plus h squared minus 2a minus 2h. Okay. So now this is equal to f of a plus h, which is this, right? Let's write that again. Okay. Minus 2a minus 2h. Okay. Minus now the other one, a squared minus 2a, all over h. Okay, let's distribute that. So we're going to get a squared plus 2ah plus h squared minus 2a minus 2h minus a squared plus 2a all over h. Just distributed the negative. But now look at what happens. A squared and negative a squared will cancel each other out. So will negative 2a and positive 2a. So now what I have is 2ah plus h squared minus 2h all over h. Now can I factor out an h? So I get 2a plus h minus 2 over h. H's go away. I'm left with 2a plus h minus 2. Yeah.
So how can you just take out the a squareds and minus h?
It didn't take them out.
But
No, because you had a squared minus a squared.
oh, so cancel it out because then
Yeah.
it's like.
I just added to 0.
Oh, that was like just an adding subtract.
Yeah. Okay, so the next function we have is f of x equals 3. Okay, let's see what this looks like. F of x equals 3. So 1, 2, 3. Basically, that's just a horizontal line through 3, right? Okay, so this is f of x equals 3. Okay, what's f of 1 here? What's f of 5?
3.
What's f of a? 3. Okay, so it's as simple as that. F of a is just equal to 3. So now f of a plus h minus f of a over h, right? We know that, okay, so this is h. We know that f of a is 3. Okay, f of a is 3. What's f of a plus h then? Also 3. So this is just 0 over h, 0. Okay, awesome. Okay, let's talk about domain. If a function is given to you without a specific domain, then we can determine the domain of that function. It'll be the implied domain of the function. Basically, this implied domain is all of the values of x that will give defined values for the function, right? So what values can I plug in so I don't get something undefined, okay? The way you do that to find the implied domain, you kind of work backwards. You say, okay, what values do not work in this function? And you exclude those values. And so when would like a value not work? You would either get something divided by 0, or you would get something like a negative in a radical, right? In a even root, right? So we're going to exclude values that would result in division by 0 or the even root of a negative number. So for example, look at this one. X squared minus 4 over x plus 2. So we know x cannot be negative 2, right? So if you look on a number line, this is negative 2. That's out. But everything else is okay for the domain, right? So the way I would write that in interval notation is negative infinity to negative 2 union negative 2 to infinity. Okay? Look at this one. You have the square root of x minus 2. So we know that the radicand, x minus 2, should always be greater than or equal to 0. So x should always be greater than or equal to 2. So to write the domain, it's going to be 2 to infinity. All right? Yeah.
Can you explain again the difference between when you use bracket and when you use parentheses?
If it's greater than or equal to, like a closed circle, it's a bracket. If it's just greater than, it's a parenthesis. So in this case, you cannot have negative 2. So it's a parenthesis.
And infinity is always
Yeah. Okay. Yeah. Okay. Polynomial functions. So next what we're going to do is just different functions and figure out their domains. I've split them into 3 different parts. First one is polynomial functions. We all remember what polynomial functions were. The domain of any polynomial function is all real numbers. No thinking involved, no math involved. So this one, polynomial function, the domain is negative infinity to positive infinity. Here, quadratic function, cute little polynomial, the domain, negative infinity to positive infinity. Done. Okay. The next category we're going to do is a rational function. Okay. For the domain of a rational function, we have to exclude every number. We have to exclude every number that makes the denominator 0. So, take a look at this one. Let's see where this denominator equals 0. Well, first let's factor. Okay? So now we're going to set the denominator here, and we're going to say this cannot equal 0. So x cannot be negative 4 or 3. Okay, so if you look at a number line, x can't be negative 4, x can't be 3, but anything else is fair game, right? It's part of the domain. So the domain will be negative infinity to negative 4, union, negative 4 to 3, union, 3 to infinity. All right? You obviously don't have to draw the number line, right? Okay, let's do this one. Okay, let's do this one. But to show work, right, you should show, to justify your answer, you should show setting the denominator equal to 0. Okay, so t can't be 1 or minus 1. So the domain is negative infinity to negative 1, negative 1 to 1, 1 to infinity. Yeah.
So for rational functions, we likely have like 3 or more like things that are being used.
We're not going to generalize.
Okay.
Yeah, because it could, yeah, we're not going to generalize. Okay, so here we go. For this one, what would be the common denominator of this?
X plus 8, x.
Right, so x plus 8 can't equal 0, and then x minus 10 can't equal 0. So x can't be negative 8, x can't be positive 10. So the domain will be negative infinity to negative 8, negative 8 to 10, 10 to infinity. Okay, next one. set the denominator equal to 0. We can't factor this. So x squared equals -1. Already, right? Even when you take a square root, right, there is no real value for which the denominator is 0. If there is no value for which the denominator is 0, then we have no issues. So the domain is just -infinity to +infinity, all real numbers. This is how we're going to write all real numbers. All right? Questions? Evan.
As long as you can't square root if it's imaginary.
Move on to radical functions. In radical functions, there are two categories. So we have to look for whether it's an even root, right? And if it's an even root, then the radicand has to be greater than or equal to 0. But if it's an odd root, then the domain is all real numbers, right? Because there is no negative positive situation in an odd root. Okay, so let's take a look. This one here, even root. So definitely 7x minus 70 has to be greater than or equal to 0. So 7x has to be greater than or equal to 70. X has to be greater than or equal to 10. Okay? So the domain will be 10 to infinity, but included with a bracket this time. All right? Here, what's the domain? All real numbers. Yeah, the root is odd, so it's all real numbers. Okay? All right, next one. What about this one? Is this an even root or an odd root? It's an even root. Okay, so let's write it as an even root. Okay, so let's write this as an even root. So this will be the square root of 9x minus 2 cubed. So again, 9x minus 2 cubed has to be greater than or equal to 0. So 9x minus 2 has to be greater than or equal to 0. That means x is greater than or equal to 2 over 9. So the domain is, in brackets, 2 over 9, comma, infinity. Like this. Okay. Now look at this next one. Now we have a root, an even root, but it's in the denominator, right? So again, as far as the root is concerned, it has to be greater than or equal to 0. But since it's in the denominator, can it equal 0? No. So because this is in the denominator, now we have to say x plus 2 is just greater than 0. It cannot be equal to 0. So x is greater than -2, which means the domain is -2 to infinity, but with parentheses at -2. Okay? Fun, right? No, because then it would be negative. Yeah. Okay. Okay, guys, I can't stop every time. Yeah, go.
I just for the rational, if they were in the denominator, why could we equal them to 0 for the rational?
No, we're not. We're saying we're excluding that point. We're not saying it can. We're seeing which point equals 0, and then we're excluding it. Okay, so this one. Okay, so take a look at this one. Now we have two situations. We've got a root, but we also have a situation in the denominator, right? So right off the bat, we know from the denominator, x can't equal 6. But now the numerator, right, is a radicand as an even root, so we're going to say x minus 3. Now, is that going to be greater than 0 or greater than or equal to 0? Greater than or equal to 0, so x is greater than or equal to 3. And now we've got battling restrictions, right? Let's put these restrictions on here. Let's see what we're looking at. This is 3. This is saying it could be greater than or equal to 3. But the other one, the denominator is saying, okay, but it can't be 6. So we have to split the domain, right? So the domain is going to be 3 to 6, closed on 3, open on 6, union 6 to infinity. So now this includes all the numbers up to like 5.99999, doesn't include 6, and then 6.00001 is also included, right? Up to infinity. Okay, lastly, this one, the only issue we have for f is in the denominator. So 2x minus 3 greater than 0. X is greater than 3 over 2. And that's it. So the domain is 3 over 2 to infinity. Okay. Now, still in the category of radical functions, right? Still in this category of radical functions, all of the ones we did with radical functions were ones where the radicand was a linear function, right? 9x minus 2, 2x minus 3, and so on. Well, what if inside the radical you have a nonlinear expression, right? If you have a nonlinear in a radical, then there is a 3-step process. We're again going to set the expression equal to 0 and solve. Then we have to create a sign chart with the zeros. Then we're going to choose the regions which are positive. Okay, so let's do that. So look here. I have a radical. I know that the stuff inside has to be greater than or equal to 0. So let's do that. Right? This is non-linear now. So to solve this, we're going to factor okay. Now, what are the zeros of this? 5 and negative 3. So on a number line, I put negative 3 and 5. You guys remember this from last year? Now we have the number line, and I put these two values on there. Into how many regions did we divide the number line? 3 regions. What I need to do is test points from each of the regions and see if I'm going to get positives or negatives. So let's do it. From the first region, we're going to pick negative 4. Okay, you can plug that into either x squared minus 2x minus 15 or the factored form. I actually prefer the factored form, right? So I like to plug it into here. Now, we don't care about the values, we just care about the sign. So negative 4 minus 5 will give me a negative value. Negative 4 plus 3 will also give me a negative value. Negative times negative is positive, so I put positive here. Okay. Between negative 3 and 5, what's my favorite number? 0. So put 0. 0 minus 5 gives us negative. 0 plus 3, positive. Together, that'll be negative. Lastly, let's pick like 6. First parenthesis gives you what? Positive. What about the second one? So that's positive. Now, you want this to be greater than or equal to 0. So you want to pick the regions that gave you pluses. And now, you just need to write that as your domain, right? So the domain, okay, if I want to color code it, that first region is negative infinity to negative 3. Open or closed? Closed, because we're allowed to have it equal negative 3. Union 5 to infinity. That's the domain right there.
Negative 3
It'll be 0 in the radical, which is okay. Okay. All right, let's move on. Okay, so as I was saying in the other class, if math models real life, then it's about piecewise functions. Okay, so look, so if you think about any situation, right? The economy. If you come up with a function to model the economy at a given time, 6 or 7 years later, that's going to change because things change. So you need another function. And then, 7, 8 years later, it's going to change again. So you need another function. So already you've got a piecewise function. If you look at a span of like 25 years, right? You've got 1, 2, 3 different types of functions. So moving ahead, right? Calculus is all piecewise functions because, again, nothing. We're going to do an example right now with a car traveling, right? Well, it's very unrealistic for anything to be traveling at the same speed forever and ever and ever, right? Things slow down, things change, things stop, right? So it is all piecewise functions. So let's do this. We're going to graph this. Where is the boundary for this one? 0. So you see that the domain, right, for each of the functions is x is less than 0, x is greater than or equal to 0. So one function is graphed to the left of x equals 0, and another one to the right of x equals 0. Now, if you want to do it the way we did it last year, in the first region, to the left of 0, I'm going to graph this. So, last year in Algebra 2, I teach students how, to do this with a table. So first, you plug in the boundary point. And then y will be, so x is 0 and y will be 2. And here, this will have an open circle. So at 0, 2, there will be an open circle. And then what's another point we can plug in that's in that domain? -1, not 1, because 1 is not in that domain. -1, and then that will give me how much? 3. Okay, so when you graph that, it looks like that. Okay. Okay, next. This other one. Now, this other one is a parabola, right? X squared plus 2. We know exactly how that looks, right? The vertex is at 2, 0, and it's going to be a parabola going up. So, if you like, the first boundary point is 0, and this is going to be a closed circle. The y value is 2. So, I go to 0 and 2. I already have an open circle there. Now, there's a closed circle. If they coincide, open and closed, just make it closed. And now, if I put in another point, right, 1, that'll give me 3, right? If I put in, you can put in however many points you want. If you want to put another one, 2, that'll give you 6. Now, I know that this is a parabola. I know what a parabola looks like, so I just make it a parabola, okay? The purpose of this class is if you have any function in front of you, you should be able to get a good idea of what it looks like at a moment's notice, right? And you should be able to graph a pretty accurate function. And then you should know from the context which of those points need to be precise and which don't need to be so precise, right? So we're moving away from like the Algebra 1, okay, when x is 0.75, y is 3.72. We're moving away from that, right? The mundane. But you need to have like this, like, general view of everything. Okay, let's go to another piecewise function. The speed v of a vehicle in miles per hour can be represented by the following piecewise function where t is time in seconds. Fabulous. Okay, find and state the significance of each of the following. So this function is v of t. That means the independent variable is t, the dependent variable is v. We already know that just by looking at v of t, right? So now if I want v of 180, right? 180 stands for the time. Okay, So now I need to plug 180 into something. Which one am I going to plug it into? The middle one, right? The middle one. Why? Because these are the domains, and then 180 falls within the domain of 15 to 240. So then how much is V of 180? 60. Okay, great. But it also says state the significance of each of the following. So what have we found?
Speed is 60 miles per hour. 30 seconds.
Right, but the dependent variable and the independent variable are switched there, right? So yeah, so at t equals 180 seconds, the vehicle is traveling at 60 miles an hour. Or you can say the speed of the vehicle is 60 miles an hour, right? So you see how I have like defined all of the pronouns. It's not like when it's 180, then it's 60. Like there is none of that. It's very, very specific. I have quantities, I have units, right? No mph, please. Miles per hour, like in math, okay? I literally, no mph.
Just M over H.
Miles, that's meters per hour. Miles is mi. Okay, V of 0. What's V of 0? Right, it's 4 times 0, which is 0. So at t equals 0, the seconds, the speed of the vehicle is 0 miles per hour. Okay? Okay. Whew. All right, let's graph one more. All right, so here we have a function, and then we've got part A and part B. A and B are independent of each other, right? One doesn't depend on the other, okay? So let's just do that. Okay, so why don't you find f of negative 2 and f of 3? Plug them into the proper functions. So what's f of negative 2? Okay. And what's f of 3? Right. Okay, now let's graph. Okay, so for the first one, we're going to do this without a table, right? For the first one, you're going to first use x equals 0 and then y equals 0, and it's going to be an open circle. And then look, I have a negative x for that. I know exactly what negative x looks like. It's right? I can reproduce that. I can draw that. So that's what that looks like, right? I don't know why I can't do straight lines. My pen keeps sliding. Okay. Next. Okay, so next I have x squared from 0 to 1. Again, when x is 0, y is 0, but it's a closed circle, so I close it. When x is 1, y is 1, but it's a closed circle. But also the function is x squared. That's a parabola, right? So I got to give it a curve like a parabola. Lastly, I have x equals 1. Y equals 1 for x is greater than or equal to 1. So here, it's just going to be 1. Fabulous. Okay. All right. Last but not least, we should also be able to write functions for these things, okay? So when you have a graph and you want to produce a function for it, you essentially have to write a function for each of the 3 components. Here I have 3 segments. I need to write 3 equations of a line. And these are easy ones because you've given the y-intercept and everything. But so, okay, so for this first one, the slope is a half. right? And then you're given the y-intercept is 0. And even if you were not given the y-intercept, right, you all know how to write an equation of a line. So the equation of this is going to be half x. That's it. So now f of x is equal to, this first one is half x, okay? If, what's the domain of that segment only? -2 to 0. So only here we use set notation. So -2 less than or equal to x less than or equal to 0, because they're both closed circles. Hang on. I'm going to finish this and then I'll take questions. So this next one, right? Slope is what? -2. And then the y-intercept is 2. So this one is y equals -2x plus 2. So -2x plus 2. If, okay, what's the domain here? 0, open, right? Less than x, less than or equal to 1. Remember, this is just the x values. And then the last one is y equals -1. I just put -1 if, and then it's from 1 to 3, right? So 1 less than x less than or equal to 3. And then, so it's important, like, the domain of each of these doesn't really depend on the other one, right? So it doesn't have to pick up where the other one left off. There could be a gap in the middle, right? All right. Okay, now any questions? Okay, Micah.